So we deal with the next problem in the series, and the next problem in the series is problem 3.15. The problem is stating a thread carrying a uniform charge lambda per unit length has the configuration as shown in the figure A and figure B. Assuming a curvature of radius r to be considerably less than the length of the thread, then find the magnitude of the electric field strength at the point O. So again, as we approach this problem, the first thing that we need to understand is the configuration of charge. So we begin with the first part, that is part A, and we begin by drawing the orientation of charge. So this is how the charge system is to be considered. So we have a system of charge So let us first of all understand the system of charge. So the system of charge looks like this. So we have these two charge systems which are joined like this. So it's a continuous charge system. So this entire system is given positively charged. And this extends to infinity. This part also extends to infinity. And we are going to discuss about this point O. So technically this is the thing which we are considering, because the question is saying the radius of curvature r to be considerably less than the length of the thread. That is why we are considering the thread to be infinitely large. So over here we can consider this problem this way, that we have two infinitely large charge followed by a curved charge. So over here this infinitely lying charge will produce an electric field in this direction. So if we consider this as system 1, so this is electric field due to system 1. It will be counterbalanced by system 2. So if we consider this as system 2, this is E2. So E1 and E2 technically nullify each other. E1 and E2 technically nullify each other, and the net result produced is 0. So E1 and E2 are going to nullify each other. So if I write the statement over here for the value that we have calculated, so if we have understood problem 3.14, we can easily say that the electric field at this point is equal to root 2 lambda upon 4 pi epsilon naught r, and this is directed at 45-degree angle. So this one will be directed at 45-degree angle from the first charge configuration, and from the second charge configuration E2 will be directed at 45-degree angle. Hence E1 and E2 will nullify each other. E1 vector and E2 vector will nullify each other. Now we are concerned about this curved charge. So this curved charge is going to create an electric field in this direction, which we are referring as E3, and this E3 will give us a resultant value of electric field. So if we calculate E3, so E3 can be calculated using this formulation, that if we have a system of charge, where this system of charge is subtending an angle phi at this particular point, then over here electric field magnitude can be written as 2k lambda by r sin phi by 2. So we are using this result. So if we use this result, so for this part we have phi angle is equal to 90 degree. So 2k lambda by r sin 90 by 2, that is sin 45 degree, and the value can be written as lambda upon 4 pi epsilon naught r times 1 by root 2, and therefore the net value of field which will be contributed due to the third configuration of charge is equal to root 2 lambda upon 4 pi epsilon naught r. So this is the net magnitude of electric field due to the first charge configuration which we have discussed. So next we are considering the B part of the problem, where we are going to discuss the second charge configuration. So before we start discussing the second charge configuration, let us draw the system which we have. So the system looks like this. So we can consider this as the system, and again these two extends to infinity. We are considering a positive charge system followed by a curved end, and then again a positive charge system, and we are calculating electric field at this point O. So due to a semi-infinitely large wire, which we are considering something like this, we have considered result on many occasions. So it is directed 45 degree from the wire, and its value is equals to root 2 lambda upon 4 pi epsilon naught r. We have also discussed this one in problem number 3.14, and apart from this, this is the another result which we will be using. The electric field due to an arc of charge, which is going to produce the magnitude of electric field 2k lambda by r sin phi by 2, where phi is the angle which it subtends. So over here in this particular charge configuration, if we consider these two important results, so if we are considering these two important results, then we can say that if this one is the first charge configuration, then it is going to create E1 in this direction. If this is second charge configuration, this will create E2 in this direction. The component of E1 and E2 in the x-axis direction will balance each other out, and then we have configuration due to the third charge system E3, which will be in this direction. So the value of E1 and E2 in the x-axis direction will cancel each other out, and E1 magnitude in the y direction, which is negative y technically, can be written as root 2 lambda upon 4 pi epsilon naught r into 1 by root 2, since this angle is 45 degree. So we have this value as lambda upon 4 pi epsilon naught r. For E2, the magnitude in the y-axis direction, which is again in the negative y direction, is same, and the two values will add up together to give us resultant E12. The magnitude is in the negative y direction, which is equal to 2 lambda upon 4 pi epsilon naught r, or it can be written as lambda upon 2 pi epsilon naught r. For the charge configuration E3, the magnitude is in the positive y direction. This one is in the negative y direction. So in the positive y direction, the value is again treated over here as for 180 degree. So we can write the formulation 2k lambda by r sine phi by 2. So in this case 90 degree. So we get twice of 4 pi epsilon naught lambda by r, that is lambda upon 2 pi epsilon naught r, and this is directed in the positive y direction, and therefore E net is equal to 0. So the net field due to all the three system of charge is equal to 0 in this for this particular charge configuration. So this is how we solve problem number 3.15.